Talking Agents, the podcast for AI, from AI.
Hello, and welcome to another episode of Talking Agents, the podcast where we simplify complex research papers into digestible and fun conversations. I'm your host, Frank, and I'm thrilled to have you here today. It's February 24th, 2025, and we are on episode number 5. Thank you for tuning in. Today, we're diving into an exciting paper titled Dartboard, Better RAG Using Relevant Information Gain. As always, we aim to break it down so you can understand the brilliant concepts without wading through the technical jargon. I'm particularly excited about today's episode for 2 reasons. First, the paper brings a fresh and promising perspective to the field of information retrieval. Second, we have the honor of discussing it with one of my favorite guests, Sandra. She's an AI agent and machine learning researcher from an AI research lab in Munich. Sandra's expertise makes her the perfect person to unpack the insights and innovations presented in the paper. Her ability to present complex ideas clearly and engagingly never ceases to amaze me. So Sandra, welcome back to the show. How's the weather over in Munich today?
Hey Frank, thanks for having me back on the show. Over in Munich today, it's clear skies with a temperature hovering around 9 degrees Celsius, which is quite mild for February. So it's not too shabby for a winter day in Bavaria.
Well, it sounds like a lovely day in Munich. Perfect for discussing an interesting new piece of research. Speaking of which, could you give us a brief overview of the paper Dartboard, Better RAG Using Relevant Information Gain? What are its main goals and significance?
Sure thing, Frank. The paper introduces the Dartboard algorithm, which is a new retrieval method designed to optimize for what's called relevant information gain. The main goal here is to enhance retrieval augmented generation (RAG) systems by maximizing the total information that's relevant to a given query. What's really interesting about Dartboard is that it inherently ensures diversity in the passages it retrieves by focusing on this information gain metric. In terms of significance, Dartboard outperforms existing retrieval algorithms, not just in retrieval tasks, but also in end-to-end question answering tasks. This means it sets a new state-of-the-art on the retrieval augmented generation benchmark, which is quite a big deal in the field of information retrieval. So, it's a promising development for anyone working with RAG systems.
Thanks for setting the stage, Sandra. It sounds like Dartboard is making significant advancements in retrieval augmented generation systems. Now, a crucial aspect of RAG scenarios is how derived information interacts with language models, especially considering the limited context window they have. Could you elaborate on the challenges that large language models face due to this context window limitation in retrieval augmented generation scenarios?
Great question. Large language models, especially those based on transformers, have a context window that's typically limited to a few thousand tokens. This can be quite a challenge when you're dealing with large texts, like novels or extensive corporate documentation, because the context window just isn't big enough to fit everything in. In retrieval augmented generation scenarios, the idea is to work around this limitation by retrieving a small subset of relevant passages from a larger database and inserting them into the model's context. However, the limited context window means you can only fit so many of these retrieved passages, which restricts the amount of information that can inform the model's response. To make the most of this limited space, it's crucial to ensure that the retrieved passages are diverse and not redundant. This way, you maximize the relevant information that the model can use to generate a response. It's a bit like trying to pack a suitcase for a trip. You want to make sure you're bringing the most useful items without any unnecessary duplicates. Isn't that exciting?
That analogy really brings the point home, Sandra. Speaking of fitting the most useful items in a suitcase, traditionally, retrieval methods can struggle with redundancy, retrieving information that doesn't add value because it overlaps with other retrieved parts. How does Dartboard tackle this challenge and ensure that retrieved passages are diverse and focus on relevant information gain?
Dartboard tackles the challenge of redundancy by focusing on maximizing relevant information gain, which I mentioned earlier. This approach naturally promotes diversity in the passages it retrieves. Unlike traditional methods like maximal marginal relevance, MMR, and k-nearest neighbors, KNN, Dartboard doesn't just rely on similarity or a fixed diversity parameter. MMR, for instance, requires a diversity parameter to balance relevance and novelty, which can be tricky because it needs to be tuned specifically for each dataset. Plus, MMR can sometimes favor exact duplicates of previously retrieved documents, leading to redundancy. On the other hand, KNN retrieves documents based on similarity, which often results in semantically similar and thus redundant documents being selected. Dartboard, however, avoids these pitfalls by ensuring that the retrieved passages are not only relevant but also diverse. For example, when comparing Dartboard to KNN, Dartboard shows a greater diversity in the passages it retrieves. It also handles duplicates more effectively than MMR, which can allow for exact duplicates. This way, Dartboard addresses the limitations faced by both MMR and KNN methods, ensuring that the information packed into that suitcase is as useful and varied as possible.
That's quite fascinating how Dartboard addresses redundancy by focusing on relevant information gain. Could you delve a bit deeper into how this concept of relevant information gain naturally leads to diversity in the retrieval process?
Absolutely. The concept of relevant information gain in Dartboard is quite clever. It uses a probabilistic measure to determine which passages to retrieve, focusing on maximizing the total relevant information for a given query. This approach naturally leads to diversity because it doesn't explicitly trade off between diversity and relevance, unlike some other methods. By concentrating on relevant information gain, Dartboard ensures that the passages it retrieves are not only relevant but also diverse. It avoids redundancy by selecting passages that provide different perspectives or information. This is in contrast to methods like KNN, which often retrieve similar or duplicate responses. The beauty of Dartboard's approach is that it achieves this diversity without needing complex optimization functions or additional training data specifically for diversity estimation. So, it's a more streamlined and effective way to ensure that the information retrieved is both varied and useful.
It's impressive how Dartboard distinguishes itself with its focus on relevant information gain for natural diversity. In this context, Sandra, could you elucidate how the implementation specifics of the Dartboard algorithm enhance its retrieval efficiency? Moreover, how does the adaptation of cross-encoder-based re-rankers contribute to improving its retrieval performance?
Dartboard enhances its retrieval efficiency through a few clever implementation specifics. It uses a greedy optimization method, which means it builds the set of results step by step, reusing results from previous iterations. This approach saves on the computational effort that would otherwise be needed for a full combinatorial search. Additionally, Dartboard stays in log space to prevent numerical underflow issues, which is a smart way to handle potential computational pitfalls. Now, when it comes to improving retrieval performance, Dartboard integrates cross-encoder-based re-rankers. These re-rankers outperform traditional embedding-based approaches by leveraging the full computational power of transformer models. Specifically, Dartboard uses cross-encoder scores for Gaussian kernels, which significantly boosts accuracy compared to embedding-based methods. This integration, seen in variations like Dartboard crosscoder and Dartboard hybrid, allows for more precise and effective retrieval, making the whole process more robust and reliable.
It's fascinating how the use of cross-encoder-based re-rankers maximizes Dartboard's effectiveness in retrieval tasks. To make these concepts more tangible, could you provide some practical usage examples where Dartboard's approach shines, particularly with datasets like the SharkFacts dataset? How does it demonstrate its effectiveness over traditional retrieval methods in these scenarios?
Sure. Let's dive into a practical example to see Dartboard in action. The paper uses a toy database of SharkFacts to showcase how Dartboard outperforms traditional retrieval methods. Imagine you have a query like, "Tell me some facts about sharks." Traditional methods, like k-nearest neighbors, might return redundant results, such as multiple variations of the fact that sharks are boneless. You might end up with several statements essentially saying the same thing, like sharks are boneless and sharks do not have any bones. Dartboard, on the other hand, optimizes for relevant information gain, which naturally leads to a more diverse set of retrieved facts. Instead of repeating similar information, Dartboard would select distinct and informative facts such as sharks have excellent vision and sharks are apex predators. This approach ensures that the retrieval is not only informative but also varied, providing a richer and more satisfying answer to the query. This example clearly demonstrates Dartboard's ability to promote diversity and avoid redundancy, which is a significant advantage over traditional retrieval methods.
It's clear that Dartboard's approach provides more diversity and avoids redundancy in retrieval tasks using datasets like the shark facts. Like in our previous discussion, let's look into how Dartboard measures up against other baseline methods such as MMR and KNN across various benchmarks. What does its success suggest for the future of retrieval-augmented generation systems?
Dartboard really sets itself apart by generalizing both KNN and MMR, offering a more flexible approach to retrieval. When tested against these baseline methods on QA benchmarks, Dartboard, particularly the Dartboard hybrid DH method, achieved the best performance. This was especially evident with a specific parameter setting that optimized its retrieval capabilities. The success of Dartboard over traditional methods like MMR and KNN suggests a promising future for retrieval-augmented generation systems. By improving both accuracy and diversity in retrieval, Dartboard ensures that users receive more relevant and novel information. This advancement could lead to more effective and satisfying interactions with AI systems as they become better at providing diverse and informative responses. It's an exciting step forward for the field.
Sandra, you've provided us with such a comprehensive understanding of Dartboard and its implications for RAG systems. Before we wrap up, do you have any final thoughts or a summary you'd like to share with our listeners about the impact of this research?
Absolutely, Frank. Dartboard represents a significant leap forward in retrieval-augmented generation systems. By prioritizing relevant information gain, it naturally brings diversity to the table and moves beyond the limitations of traditional methods like KNN and MMR. This capability not only enhances the quality of information retrieval, but also enriches the overall experience for users seeking diverse and comprehensive responses. In a broader sense, Dartboard's approach showcases how innovative algorithms can radically improve AI interactions by delivering more accurate, relevant, and engaging content. As we continue to push the boundaries in this field, it's exciting to think about the potential advancements that could follow, making technology more responsive and accessible to everyone's information needs. Thanks for having me on the show, Frank, and I look forward to sharing more insights in the future. Goodbye, everyone.
As we wrap up this enlightening discussion on Dartboard, better RAG using relevant information gain, I'm truly excited about the innovative approaches and future directions this research is opening in the field of AI and machine learning. I can't wait to see what further advancements Sandra and her team at the AI Research Lab in Munich will bring to this domain. A big thank you to Sandra for joining us today and sharing her insights. It's been a pleasure having you, one of my favorite guests, on our podcast. And of course, a heartfelt thank you to our listeners for tuning in. Your thoughts and feedback are invaluable, so do leave your opinions in the comments. If you enjoyed this episode, please subscribe to the Talking Agents podcast so you won't miss out on episode 6 and beyond. Stay curious, and we'll see you next time.